We're going to do Rational Exponents Basics. And I'm going to do the basic exponent rules here. And I'm going to give you the rule, actual rule, in words and in symbols. And then I'm going to give you actual number examples of each so that you can see the rule with symbols, see it in words, and then see it with actual numbers. Exponent rules number 1. Multiply like bases. To multiply like bases raised to exponents, simply add their exponents. This is a basic rule. Almost everybody knows this rule. They like this rule. Here is a symbolic form to write this as x to the a times x to the b, so they have like bases, equals x to the a plus b. You just add them together. So here I have here's your symbols, here's in words. Now I'm going to give it to you with numbers. So if I had x to the 5th times x cubed, since they have the same base, I simply add their exponents as x to the 8th. And then I'm going to give you fractional ones too, because you can have fractional exponents. You're probably not as comfortable with that, but it works the same way. So I have c to the 2/3 times c to the 1/6. Since the base is the same, if I find a common denominator and add them, I would have c to the 5/6. So that's rule number 1. Rule number 2 of exponent rules are divide like bases. In words, to divide like bases raised to exponents, simply subtract their exponents. And in the little cloud here, I have the symbolic form of this rule. It's x to the a divided by x to the b. They have the same base, so I simply subtract their exponents. Now, a couple numerical examples. Here's the first one. I have x to the 6th over x squared. Since they have the same base, I simply subtract them. I have x to the 4th. And again, one with fractions, so that we get better at our fractions. I have b to the 4/5 divided by b to the 4th. They have the same base, so I have to subtract these fractions. But if I find a common denominator and subtract them, I would actually get b to the 11 over 20. So this would change to 16 over 20. This would be 5 over 20. And 16 minus 5 is 11 over 20. That's where that came from. So these are the two most common ones. Everybody knows what to do on those. Okay, exponent rule number 3. Power raised to a power. So I like this one. It's power to the power. That's what I always like to say. So let's look at this a little bit so you can see it. All right, so we're going to raise a base that is raised to an exponent to another exponent, simply multiply their exponents. That seems like a lot. So let me show that to you in symbolic form. Okay? If I have x to the a and the whole thing is raised to the b, you can simply write it as x to the ab. So I like to call this as power to the power. So power to the power. And you actually multiply. Now, in the symbolic form here, it's kind of hard to see how this works. So let's look at this one right here, numeric. So I have x cubed, all of it's raised to the 4th. Really what that means is I can write x cubed 4 times. And if I wrote it 4 times, I'd add them all up, and 3 plus 3 plus 3 plus 3 is 12. But instead of doing that, I just can simply multiply those two, and it's x to the 12th. So you really can see how this rule works right here. Now, of course, I have to do a fraction. So if I have a to the 2/3 and the whole thing is raised to the half, because it's power to the power, I simply multiply. When you multiply the fractions, you multiply the numerators and the denominators. So I get a to the 2/6, and that reduces down to a to the 1/3. So this is a really neat rule. It saves you a lot of time if you're raising a power to another power. So it's power to the power. Okay. Exponent rules number 4. The product of two bases. Now these bases are different. We've been using like bases for all the other rules. So to raise the product of two bases, that's a 2, sorry. To raise the product of two bases to the same exponent, raise each base to that exponent. So let's look at the symbolic form right here. I have x times y, different bases, they're multiplied together, raised to the a. That is the same as saying x to the a times y to the a. So you're basically raising the whole thing, but you can split it up like this and write this with the multiplication sign in the middle. Okay, let's look at some numerical examples so that you can see how it works. So I have x squared times y, two different bases, all raised to the fourth. Now remember, power to the power still works here. So if I'm raising this to the fourth, I'm really saying 2 times 4, so that's x to the 8th. And this is a little 1, even though you don't see it, 1 times 4 is 4, so that's y to the 4th. And you don't need to show the multiplication. It's understood if you write it just like that, x to the 8th, y to the 4th. Again, let's use fractions. Here's my other example, parentheses a to the 5th b, all raised to the 1/5. Now we know there's multiplication going on here, it's understood. So I'm going to raise each one. Remember, power to the power, and if it makes you feel better, put a little 1 there for an exponent. It's understood that it's there, but if it makes you feel better so you don't make mistakes. So I've got a, so I got to say 5 times 1/5. Well, if you were to multiply that, if you want to think about it over 1, it'd be 5 over 5, or 1. That comes to a to the first power. And I don't need to write the first, so I just simply write it as a. And then b to the first times that, 1 times 1/5 is 1/5. So it's going to be a, b to the 1/5. And again, the multiplication is understood. So this is a product of two bases. Okay. Our last one here is, of the exponent rules, is quotient of two bases. So to raise the quotient of two bases to the same exponent, raise each base to that exponent. So this is similar to the product of two bases, but we're now dividing. So let's look at our symbolic form. So here I've got the rule, here it is in words, here's our symbolic form. So if I have x divided by y, different bases, all raised to the a, it's same as saying x to the a, y to the a. So you just basically got rid of your exponents and did power to the power, because these are little ones there, if you will. So let's look at this one right here. I have x squared over y, all raised to the third power. So remember, power to the power, I'm saying, so you do 2 times 3, so that's x to the 6. And if you need to, put a little 1 here, you have to raise that to the same power, so that's going to be y cubed. So it's x to the 6 over y cubed. Now let's try our last example with, we'll use fractions. I have a over b to the 7th, all raised to the 3/7. If you need to, put a little 1 there because that's understood. So if I do power to the power, that's going to be a to the 3/7. Over, now I have b to the 7th times 3/7, and if you need to, put that over a 1 if you need to. That would be, the 7s would cancel out, so I'd end up with just a 3. So that's b cubed. So my answer would be a to the 3/7 divided by b cubed. Those are your basic rules of exponents.